a negative times a negative equals a positive. Various proofs have been presented, including those involving that, number line, and logic. Let's assume that a negative times a negative equals a negative. What would happen? This might lead to a new proof. Assume that minus 2 times minus 3 equals minus 6. Then, what would be a negative times a positive or a positive times a negative? Since multiplication is commutative, both results are the same, so we only need to consider one case. We'll represent the result of this multiplication as x. Every number is positive or 0 or negative, so x must be one of these three, plus 6, 0, minus 6. However, minus 2 times plus 3 cannot equal 0. For x to be 0, according to the rules of multiplication, at least one of the two numbers must be 0. But these are not 0, so this can't be 0. Also, minus 2 times plus 3 cannot equal minus 6, which is the result we assumed for minus 2 times minus 3. If it also equals minus 6, then minus 2 times minus 3 equals minus 2 times plus 3. Rearrange this equation and factoring out minus 2. We find that the product of these two terms must be 0. So, for this to be true, this term must be 0. It means that minus 3 equals plus 3. This is impossible. This would contradict and destroy the structure of the number system. Therefore, minus 2 times plus 3 must equal plus 6. A negative times a positive must equal a positive, assuming that a negative times a negative equals a negative. Since one of the signs has changed, it seems natural that the sign of the product also changes. Now, let's go one step further. What about a positive times a positive, such as plus 2 times plus 3? The result must be positive or negative. So, this must equal either plus 6 or minus 6. What if this value is plus 6? In that case, plus 2 times plus 3 would equal minus 2 times plus 3. Rearranging and simplifying, we again find that this value must be 0. It would require plus 2 to equal minus 2. This is impossible. Therefore, plus 2 times plus 3 must equal minus 6. But this result would contradict the current mathematics. One of the fundamental rules of mathematics is that a positive times a positive equals a positive. This rule is derived from 1 plus 1 equals 2. However, if we assume that a negative times a negative equals a negative, a positive times a positive must equal a negative. Furthermore, 1 plus 1 would not equal 2. This would completely deny the fundamental rules that underpin the mathematics. This cannot happen. 1 plus 1 equals 2. A positive times a positive equals a positive. These rules are more fundamental and take precedence. Any new rules must be based on these principles. New rules that contradict these rules can't coexist with the current mathematics. The assumption that minus 2 times minus 3 equals minus 6 leads to contradictions. Therefore, minus 2 times minus 3 must equal plus 6. A negative times a negative equals a positive. And a negative times a positive equals a negative. Only then can 1 plus 1 still equal 2, and a positive times a positive still equals a positive. This is a kind of proof by contradiction to demonstrate that a negative times a negative equals a positive.